Hi everyone. Today we will learn about transformations of function. We will focus on the three types of transformations. The first one is the translation. Second one is reflection. And the third one is stress. So let's start from the first one, translation. So what is translation? Translation is a transformation that will shift the graph or the function horizontally and vertically. So we usually express the transformation in the form of a vector, of a column vector, x, y, in the first row, indicating the direction in horizontally, where the graph will shift left and right, and the second row, where the graph will move up and down vertically. So the first row will be for horizontal movement, horizontal shifting, and y, the second row will be used for the vertical shifting. So we start with the vertical translation. A vertical translation will shift the function up and down. And we have the general form of the vertical translation. Gx equals to an original function fx plus minus a, where a is a constant. If a is positive, so the function will be lifted up. If a is negative, the function will be shifted downwards. So let's start with the example. If I have an original function of fx equals to x squared, so I want to find the gx. Gx equals to x squared plus 1. So I can rewrite gx as the fx plus 1. Yeah, since fx equals to x squared, so x squared I can change it, replaced by an fx notation of the function, original function, plus 1. So if we see from the graph, if we have f0, f0 is 0. If we have f1, you see f1, this is 1, it will be equals to 1. And if we have f negative 2, so negative 2 is here, so equals to 4. Now, how about the G0? So G0, according to the expression, so it's F0 plus 1, which is 0 plus 1 equals to 1. And G1 equals to F1 plus 1, which is 1 plus 1 equals to 2. So we draw it when G0 is 1. So G0 is 1 here. F1, G1 is 2. So G1 is 2. And G negative 2 is F negative 2 plus 1 equals to 4 plus 1 equals to 5. So this one. So you can see in this example, all the coordinates of fx is being lifted upward by 1 unit. So it will be like this. So that means a notation of gx equals to fx plus 1 is a vertical translation by factor 0, 1. Yeah, the first row will be for x direction and the second one will be for y direction. That's number 1. How about number 2? Number 2, I have the same function fx equals to x squared, but now I want to express x hx equals to x squared is an fx minus 1. So again, for f0 equals to 0, f1 equals to 1, and f negative 2 equals to 4. And the hx h0 will be equals to f0 minus 1. So 0 minus 1 is negative 1, while h1 equals to f1 minus 1 equals to 1 minus 1 is 0, and h negative 2 is f negative 2 minus 1, so 4 minus 1 is equals to 3. So if you draw, h0 will be negative 1, so it's here. h1 will be 0, so here. H negative 2 will be equals to 3, so it's here. So as well as here, yeah. Negative 2 will be here. So I can draw this. So you can see that all the coordinates are moved downwards by 1 unit. So hx in the form of fx minus 1 is a vertical translation by factor 0, negative 1. Now we move on to horizontal translation. A horizontal translation will shift the function right and left horizontally, so in right and left direction. So the general form of this is gx equals to fx minus plus a. So in x direction, we do the opposite sign here. Positive a will be shifted to the left, while negative a will be shifted to the right. So let's see the example. So the original function is fx equals to x squared. So gx is, so I can rewrite gx as the fx plus 1. Since fx is x squared, so if I change x with x plus 1, so it will become fx plus 1 equals to x plus 1 squared. So I can just write this in the form of fx plus 1. So now, if we see from the graph again, so f0 equals to 0, f1 equals to 1, f2 equals to 4, yeah, f2 equals to 4, f negative 1 equals to, f negative 1 equals to 1. Now, let's find g0. So g0 if is equals to fx plus 1, so equals to f0 plus 1, which is equals to f1. What is f1? f1 is equals to 1. So g0 is 1. Okay, g1. So f1 plus 1 equals to f2. So this will be equals to 4. So g1 equals to 4. So if you see here, from f0 become g0. So you'll shift the coordinates to the left by 1 unit. Again, so g negative 1. So it is f negative 1 plus 1 equals to f0. So equals to 0. So g negative 1 will be equals to 0. So if you see, the graph will be like this. How if I find g negative 2? It will be f negative 2 plus 1 equals to f negative 1. So f negative 1 is 1. So here, yeah, for g negative 2 equals to f, the value of f negative 1. So it will be like this. So you will see that all the coordinates are shifted to the left. So gx equals to fx plus 1 is a horizontal translation by factor negative 1, 0. In the factor, we write negative for the left side and positive for the right side. But in the function notation, we put positive 1 for the left side and negative 1 for the right side movement. Yeah? So it's opposite in the function notation, but it is originally in the factor notation. So this one that you have to remember, for horizontal, it's always being opposite in the function notation. Okay, now let's try for the hx negative 1. So again, the same, if I have f0, I start with negative 2, f negative 2, here 4, f negative 1 equals to 1, f0 equals to 0, f1 equals to 1, and f2 equals to 4. And now for h x, h negative 2, so h x is equals to, so this will be f x minus 1. Yeah, remember that the fx is x squared. So if I replace x by x minus 1, so it's replacing the x here. Yeah, so this is fx minus 1. So equals to f minus 1 minus 1, minus 2 minus 1. So equals to f negative 3. If we see here, f negative 3 will be equals to here, yeah, 9, yeah. 9. H negative 1 is f negative 1 minus 1. So it's f negative 2 equals to this one, 4. H0 is f0 minus 1 equals to f negative 1 equals to 1. H1 equals to f1 minus 1 equals to f0, which is equals to 0. And H2 is f2 minus 1 equals to f1 equals to 1. So if we do it, negative 3 will be negative 2. It will be 9 here. Negative 1 will be equals to 4. Negative 1 will be equals to 4. 0 will be equals to 1. 1 will be equals to 0. And 2 will be equals to 1. So what can you see here? You can see that all the coordinates are shifted to the right by 1 unit. So hx equals to fx minus 1 is a horizontal translation by 1, 0 to the right. That's for translation. Now we continue with the reflection. So there are two types of reflection. So it's reflected by x-axis or it's reflected by y-axis. The formula is gx equals to negative fx for the reflection by x-axis. So if you remember, fx is y. So negative here is equals to negative y. So y and negative y are reflection by x-axis. This is y, this is negative y. So if we have negative fx, we have reflection by x-axis. And if we have gx equals to f minus x, so the value of gx, the x value here, for example, positive x, equal to the value of the negative x here. So that means we reflect the graph, the function, by y-axis. So that's why negative x and x are reflection by y-axis. So let's see the example. If I have now fx equals to x cubed, so the gx equals to negative x cubed. So this is equals to negative fx. So let's try again. F0 in here is equals to 0. F1 is equals to 1. F negative 1 is equals to negative 1. If you see here, yeah? Negative 1 is here. Negative 1. So the G0 is equals to negative F0 equals to 0. G1 is negative F1 equals to negative 1. So G negative 1 is negative F negative, negative 1 equals to 1. So we can see that 0, F1 is negative 1, F negative 1 is 1. You can see that this is a reflection by x-axis. So F1 here will be reflected by x-axis to become minus F1. And here, F minus 1 will be reflected into to become F1. So reflection by x-axis. So gx equals to negative fx is a reflection by x-axis. Now, how about negative x cubed? So it will be hx equals to f minus x. Yeah, because fx is x cubed. So if I replace x by the negative x, so it becomes negative x cubed. So this is the notation. So again, f negative 1 is equals to negative 1, f0 equals to 0, f1 equals to 1. And now, if I have h negative 1 will be equals to f minus negative 1 equals to f1 equals to 1. And h0 will become f negative 0 equals to f0. So stay the same. And h1 is f minus 1 equals to negative 1. So now the coordinates may be the same, but the process is different. So f1 negative 1 is equals to 1 because we reflect the value of f1 So from here to here. If you see the difference in here, we move the G1 is equals to minus of F1. So we reflect the by x-axis from here. We give the negative, so we reflect it by x-axis. But in here, it is negative x, so it's reflected by the y-axis. And here, x1 equals to negative 1, x1 is equals to negative 1. So you reflect this by y-axis. So you will have same graph, yeah. In this example, you will see it is similar, but the process, if you pay attention, the processes are different. So that means I can say hx equals to f minus x. This is a reflection by y-axis. Next, stress. Now the stress is an enlargement in one dimension only. So either in x direction horizontally or in y direction vertically. So it's only in what happened in one direction at one time. So if enlargement, we have to stretch it in both directions at the same time. But for the stretch, it's only being stretched in one direction, vertically or horizontally. So we can divide into two, horizontally and vertically. If we have vertical stretch, so we stretch the y coordinates, so we multiply the y by a. A is called as the scale factor. So, for example, now I use trigonometric function, so we can see it clearly. Sine x to become a sine to sine x. So I can rewrite this as 2fx. So that means if I have f0 equals to 0, yeah, here, f pi over 2 will be equals to 1. Yeah, you can see the coordinates. F pi will be equals to 0. F 3 pi over 2 will be equals to negative 1. So now, what is G0? So G0 is 2 of F0, which is 2 times 0 is 0. G pi over 2, so the same x value is 2 times of F pi over 2 equals to 2. So if you see the process, on the same x value, the y coordinates are multiplied by 2 equals to 0. So this is 2f 3 pi over 2 equals to negative 2. So 0, all y's will be multiplied by 2. So 0 is 0, 1 becomes 2 on the same x value, 0 becomes 0, negative 1 becomes negative 2. So it will be like this. So this is gx equals to 2fx is a vertical stretch by scale factor or SF, yeah, of 2. So we multiply all the y values by 2. How about h x? Now we have sine 2x. So again, if I have f0 equals to 0, f pi over 2 equals to 1, f pi equals to 0, f3 pi over 2 equals to -1. So h0 equals to, okay, what is this? This is an f2x. Yeah, so this is f2x because fx is sine x. So that means this is equals to f0. Yeah, 2 times 0 equals to f0, so 0. F pi over 2, so h pi over 2 equals to f 2 times pi over 2, which is equals to f pi. What is f pi? F pi is equals to 0. How about h pi? So h pi is f 2 times pi, so equals to f2 pi. F2 pi is this one, 0. So everything is 0. So, and then how do you do that? Okay, let's try some other numbers. I try f pi over 4. So if you see f pi over 4 will be here. Sine pi over 4 is equals to half square root of 2. f3 over 4 pi. So f3 over 4 pi will be here. So this is the same, half square root of 2. So let's try for the h value. So h pi over 4 will be equals to f 2 times pi over 4. So this equals to f pi over 2 equals to 1. Yeah, f pi over 2 is 1. And this one, h3 pi over 4 will become f 2 times 3 pi over 4 equals to f3 pi over 2. What is f3 pi over 2? -1. So now we draw h0 is 0, h pi over 2 is 0, h pi is 0, h pi over 4 is equals to 1. H over 4 equals to 1. 3 over 4 equals to -1. So it's here. And if we connect, what you can see, you see that the graph is being stretched horizontally by a scale factor of half. It's become half. If you see the period of the original one is 2 pi. But now the period of the new one is become half. So that means hx equals to f2x is a horizontal stretch by scale factor half. So again in here, the notation will be opposite. So in horizontal direction, the scale factor is half. So you write as 2x. Yeah. So for the horizontal, if I have hx equals to f(ax), so this is horizontal stress by scale factor of 1/8. So if I have a x/a, so this is horizontal stress by scale factor a. Yeah, so for the x-axis, it's always opposite. Okay, that's all the three transformations.